Key concept 9, target A.
Yeah, YouTube channel is at Math Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors.
We're going to start key concept 9, target A, with talking about geometric sequences. We looked at something similar in the first semester. We were looking at arithmetic sequences. Now we're looking at geometric sequences. So the definition is a list of values that have a common ratio. And it says here, basically what it is you're multiplying by the same amount to go from one term to the next. So what does it mean to have a common ratio? What does it even mean to have a ratio? A ratio is a comparison of two values that is usually written as a fraction. Okay, so for example, when we talk about speed, right, you're telling me that we're going 50 miles per hour. Okay, the two things that we're comparing here are the distance miles over time hours. All right, so we're sort of looking at something like that. Now, they give us an explicit formula that we're going to be looking at. A sub n equals a sub 1 times r raised to n minus 1. So again, we did something similar to this, but the formula was different. Although a lot of the variables here represent the same thing. So we're looking at a1, which still represents the first term. So we're going to go ahead and we're going to jump to example 1 so that you can sort of see what this looks like as we use an actual example, right? So we'll be looking at this sequence right here. Remember, a sequence is just a list of numbers. So if we were looking to identify the first term here, the first term in this sequence is going to go ahead and be 3. Okay. The next thing that they're asking for is the R, common ratio. Okay. It says here to find the common ratio R, divide any term by the previous term. Now, we're looking for what number are we going to multiply to go from one term to the next. 3 is the first term, 6 is the second term, 12 is the third, and so on. If we're thinking about purely multiplication here, we're asking ourselves 3 times what value would give me 6? That would be times 2. Okay. And then if we want to make sure that that's the same pattern, we try it with 6. 6 times 2 is 12. 12 times 2 gives me 24, and so on and so on. So the common ratio, sure enough, is 2. Now, in this sequence, it's obvious what the common ratio is, but it may not always be that way. You might find yourself with a sequence where you're asking yourself, I'm not exactly sure what I'm multiplying by. Let's say this was the case for this one, right? You couldn't identify that you're multiplying by 2. The hint here is to divide any term by the previous one. So let's say I decide to start with 24, right? So I'm trying to calculate R. I'm going to take any term. In this case, I took 24. And it says here, divide by the previous one. So the one that came right before it is 12. 24 divided by 12 is going to give me 2. And it'll work with any one of them. So let's say I decide to take 96. Divide by the one that comes right before it, 48, would still give me 2. If I took the second term, 6, divided it by the one that came before it, 3, it would give me 2. So that's another way you can find the common ratio, just in case you can't tell right away. The next one here says n is a term number. In this case, I'm telling you to find the 8th term. So we would let n equal 8. We may not always be interested in the 8th term. In this case, we are, but in another example, I might be asking for the 6th term. In that case, n would be 6. Now, an is the actual value of the term. So in this case, since we're letting 8 equal n, I can go ahead and plug that in wherever I see n. So this would really be telling us a of 8, which a tells me we have a geometric sequence. 8 just tells me I'm trying to find the 8th term. Right? In this case, 3 is the first term, 6 is the second, 12 is the third, 24 is the fourth, 48 is the fifth, and 96 would be the 6th term. So if I wanted to find the 8th term in this case, I would need to continue the pattern. So I would take 96, multiply that by the common ratio, so multiply that by 2, and that would give me 192, which is 1, 2, 3, 4, 5, 6, the 7th term. Multiply that by 2, and that's actually going to give me 384, which would be the value of my A term, 384. Okay, I sort of covered everything in this one target in this one slide. As we progress with the examples, you'll see I'll break it down a little bit so it makes a little bit more sense as we go. Example 2 says identify the first term, also known as A sub 1, the common ratio, also known as R, and write the explicit formula for each sequence. Probably what I'm going to want to do first is I see the word explicit formula, so I'm going to go ahead and write it down for myself. That's A sub n equals A sub 1 times R raised to n minus 1. Okay, it says identify the first term. So A1, the first term in this sequence is going to go ahead and be 2. They want us to identify the common ratio, R. What are we multiplying by? So you ask yourself, 2 times what would give me 8? In that case, it would be 4. And then just continue the parent to make sure. 8 times 4 would give you 32. 32 times 4 would give you 128. So sure enough, the common ratio is 4. And then the last thing they're asking us for is to write the explicit formula. So we're going to have A sub n equals, we're going to go ahead and plug in A1. In this case, it was 2. Times R, which is our common ratio, in this case was 4, and we're raising it to n minus 1. Okay, and that's actually going to be our final answer. Notice we didn't plug anything in for n because n represents which term we want to solve. For this example, they don't tell me which term I'm interested in, so I just leave n as is. Okay, looking at example B, again, identify the first term. A1 is going to be negative 80. Okay, next thing they're asking, common ratio. What are we multiplying by? That's our R. Now, we're going from negative 80 to 20. Temptation here might be to say that we're multiplying by 4, but that's not the case. If we took negative 80 and multiplied it by 4, we would get negative 320. And that's not the number that's there. It's actually getting smaller. So this would be one of the perfect examples where I can't tell by just looking. So I'm going to use the hint, which was take any term. So in this case, I'm going to take the second term. And it says divided by the one that came right before it, negative 80. If you put that into your calculator, 20 divided by negative 80, if you leave it as a simplified fraction, that's going to give you negative 1/4. If you want it as a decimal, you would have to do negative 1 divided by 4, hit the decimal point on your TI Inspire, you're going to get the decimal equivalent, which is negative 0.25. You can either use negative 1/4 or you can use negative 0.25. Either one would be correct. Just be aware that they're actually both the same answer. So in this case, I'm going to go ahead with the fraction answer, just because that's the choice I'm making. So explicit formula, AN equals, A1 was negative 80 times. Now I can use the dot to represent times, but in this case, since I'm using a fraction, I think just to play it safe, I'm going to use parentheses, which still means multiplication. So I'm going to put R in parentheses, and again, I'm going with the fraction, and then raised to n minus 1, and that would be our final answer for that one. Okay, moving on to C. C, again, identify the first term. A1 is equal to negative 3. R, your common ratio, what you're multiplying by. In this case, I know how to go from 3 to 12. 3 times 12 is times 4. In case you're thinking, well, how do I know if it's not negative? If you took negative 3 times a negative 4, that would give you a positive 12. So that lets us know that we actually want to keep it as a positive 4. And then the last thing we're sort of looking at here is explicit formula. So AN equals A1, which is negative 3, times R, which is 4, raised to n minus 1. Notice for this one, I decided to go back and use the dot to represent multiplication. Had I wanted to continue using parentheses to let me know it's multiplication, I could have done that as well. D, A1 equals first term, 0.45. Common ratio, what do we multiply? This is another perfect example where I'm looking at 0.45 and I have no idea what I need to multiply that by to get 0.9. So I'm going to take the second term, 0.9, divided by the 1 right before it, 0.45, and that's actually going to give me an answer of just 2. So what they're really multiplying by is 2. It looks complicated, but when you use the trick, it's pretty easy to figure out. And then plug it into the explicit formula. AN equals A1, which was 0.45. Again, because I'm dealing with decimals here, rather than use the dot for multiplication, I'm going to use parentheses just so as not to make a mistake. Times 2 raised to n minus 1. Final answer. Example 3. From each table, write an explicit rule. Okay, so I'm seeing the words explicit rule. So for my own benefit, right away, I'm going to go ahead and write down what the explicit rule, which is an equals a1 times r raised to n minus 1. So they want me to write an explicit formula for each of these tables. Okay. Remember, in a table, the column to the left is going to be your input, your independent, your x. The column to the right is going to be your dependent, your y. But in this case, we're not using x and y, right? So we think about the explicit rule. One of the things that you want to plug in order to calculate it is n. You need to know which term you're interested in. So n is actually going to act like my x. And then when you go ahead and you plug in n, which term you're interested in, what's going to come out is the actual value. So y is going to be my a sub n. Okay. So this would say the first term is 3, the second term is 12, the third term is 48, and the fourth term is 192. So if you wanted to rewrite that table as a sequence, the first value would be 3, then 12, then 48, then 192. Okay. In which case, A1, the first term is going to be 3. R, what are you multiplying by? How do we go from 3 to 12? Multiplying by 4. 12 times 4 is 48. 48 times 4 is 192. Make sure you double check your pattern. Just because you think you identified it right away, it's still worthwhile checking to make sure it actually holds. And then plugging it into explicit, we're going to have a sub n equals a sub 1, which is 3, times r, which is 4, raised to n minus 1. And that's going to be the final answer for 3a. Okay. 3b is similar, so I'm going to let you guys do 3b on your own. I will check out 3c just because I noticed that instead of increasing, it's actually decreasing. So remember, column on the left, x is actually n, what we're plugging in. What comes out is actually a sub n, the actual term value. And then first term is 250, the second term is 50, the third term is 10, the fourth term is 2. So if I were to rewrite it as an actual sequence, it would be first 250, comma, then 50, then 10, then 2. Where A1 is 250, R, what you're multiplying by, it is not going to be 5, okay? I can see how you would think 5 because if you work backwards, 2 times 5 is 10, 10 times 5 is 50, and so on, but I want to know what the pattern is going this way. Going to the right, so I'm going to take the second term, which is 50, divided by the one right before, is 250. You do that, you're going to get 1/5, or 0.2, also known as 0.20. I'm going to go with the decimal in this case, although I could have gone with the fraction equivalent, which is going to be 1/5, but I chose to go with the decimal. So plugging it all in, we're going to have an equals first term, 250, times r. I'm going to go with parentheses, 0.20, raised to n minus 1. And again, I could have gone with the dot for multiplication, but to me, when you have decimals already in your answer, I feel like it's an opportunity to make an accidental mistake and confuse it for a decimal. So I'm just going to go ahead and put that in parentheses, and that'll be my final answer for C. Example 4. Write an explicit rule for each given the following information. Again, right away I see explicit rule. So for my own benefit, I'm going to go ahead and write down an equals a1 times r raised to n minus 1. Looking at A says it has an initial value of 50. Initial also means what it starts with, or the first one. So they're telling us right away that A1 is 50. And it says common ratio is 3. Common ratio, we should understand that to be the letter R, which is what are you multiplying by each time? 3. And we have enough information already to write the formula. So we have AN equals A1, which is 50, times R, which is 3, raised to n minus 1. Again, notice we're not plugging anything in for n because they don't ask us to solve for any specific term. They just want us to set up the rule. Okay, taking a look at example B. Initial value of 80, so A1 is 80. Common ratio is 1/2, so R equals 1/2. Or if you want the decimal equivalent, 0.50. Plugging that into the formula, AN equals A1 is 80 times, I'm going to go ahead with the fraction 1/2 raised to n minus 1. Final answer. Example 5a. The number of subscribers to Mr. A's YouTube channel doubles every day. The channel had 800 visits after one day. Determine the explicit rule that will allow you to determine the number of subscribers after any given day. Then calculate the projected number of visitors after 1 week. Okay, so we're asked a couple things here. First thing, they want us to determine the explicit rule. Then they want us to calculate the projected number of visitors after 1 week. Projected just means sort of like an estimate. We're calculating it still. We're using math, but it's still a guess, right? Because we can't know for sure how many people will sign up in the future. So let's start by setting up the explicit rule. So I'm going to go ahead and write down what the explicit rule looks like. So AN equals A1 times R raised to n minus 1. Okay, A1 is going to be our first term. We're told the channel had 800 visits after 1 day, so that's going to be A1, 800. And then R is, what are we multiplying by? We're told that the number of subscribers to my channel doubles. If you want something to double, you need to multiply by 2. If you want it to triple, you multiply by 3. If you want it to quadruple, you multiply by 4, and so on. So now we have enough information to write the explicit rule. So we have AN equals A1, which is 800, times R, which is 2, raised to n minus 1. So this is going to be part of my answer. But keep in mind, they still wanted to know how many visitors we're going to have after 1 week. So we're actually going to have to plug something in for n. So we're going to go let n equal, n is which term we want. Now we're told that it doubles every day. So we want to know after 1 week. But notice the original measurement was 1 day. So if it's doubling every day and I want to know how many visitors after 1 week, I need to convert 1 week into days, which is going to be 7. Okay. It won't always be days. It might be minutes, it might be months, it might be years. It depends on what they tell you. In this case, I converted 1 week into days because we're told that it doubles every day. Had they told me that it doubles every minute, I would have converted it into minutes. So make sure you read each problem because each problem is a little bit different. So we're going to go ahead and plug that into the formula that we had. So we have A of n, A of 7 equals 800 times 2 raised to 7 minus 1. Okay. The A is just telling me that we have a geometric sequence. The 7 is telling me that I want the 7th term. We're going to do order of operations. Please excuse my dear Aunt Sally. No parentheses, then it tells me to do exponents. So I bring down the 800, I bring down the 2. Exponent 7 minus 1 is going to give us 6. Okay. And then we're still not done with the exponents because we still have 2 raised to the 6. So we have a to the 7th equals 800 times 2 raised to the 6. We're just going to go ahead and give us 64. And then the last thing we're going to want to do is take 64 times 800. And that's going to give us 51,200. So it's telling me that the 7th term in the sequence is 51,200, which is telling me that the number of visitors after 1 week is 51,200. So I could write that in a quick sentence. The projected, because again, at the end of the day, it's still an estimate. We don't know for sure. And that would be the final answer for this one. So notice they wanted the rule, which was this, and they wanted to know how many visitors after 1 week, which was that.